Good evening, everyone. I believe you are all well. Yes, welcome to the session for Kangaroo Maths and Science Academy. Today, I will take you through algebra, particularly for grade 11 and 12. This is one of the topics that usually most learners are supposed to get good marks from this topic because it's easy and it is one of the topics that it's usually used in other subtopics like functions and graphs. In most of the topics actually we use algebra, so it's one of the topics which is more important, guys. Right, let me just share a question which I actually wanted us to go through. Right, we know that when we are dealing with algebra, you need to actually familiarize yourself with the format of the paper and how they actually set the paper. Right, we know in most of the cases that when we are dealing with algebra, the paper usually, we already know that in terms of the format of the paper, okay guys, let me just try to move this here. In terms of the format of the paper, we know that usually, like, you need to understand that we're not dealing with algebra. The first question actually is based on factorization, and the second one is actually the examiner is testing you on how to use a quadratic formula. Then after quadratic formula, usually we have squaring both sides. Squaring both sides, expressions that require the squaring of both sides. And after that, usually we have what you call the inequalities. Then after inequalities, then they bring simultaneous equation. And then the last part, usually they will ask maybe exponents, the part of using exponents. Or if not exponents, they actually use the part of the nature of roots, where we know that when the discriminant is greater or equals to 0, it means the roots are real and equal. But if the discriminant is just bigger than 0, it means the roots are also real and unequal. Then when the discriminant is just exactly 0, we know the roots are equal. When the discriminant is less than 0, we know we have non-real roots. And one other thing in terms of the nature of roots is that when the roots are real, you must check whether they are rational or irrational. So these are the things that the examiner actually wanted you to differentiate between roots that are real and that are, roots that are rational or irrational. Then another thing very important is you need to be able to understand the law of exponents. Like, we know in terms of exponents that if the base are the same for multiplication, what we do, we take one base and add exponents. And also you must be able to reverse it again. Then the number 2, you must know that when you are dividing exponents, as long as the base are the same, then you subtract the exponents. The another thing is the issue of when you have one base with multiple exponents. So if you have 8 to the power of x multiplied by y, this is the same as 8 to the power of xy. You can just multiply the exponents of their powers. And again, you must know that any number to the power of 0 is always equals to 1. This is very important in terms of exponents. And one other thing about the issue of exponents is that also the issue of sugs, very important. That we know that when we have the square root of a number, is that number the power of half? And the nth root of a is actually a to the power 1 over n. Even the issue of saying if we have the square root of a times b, this is the square root of a alone multiplied by the square root of b. So it means even if you have this, you can still reverse it back to that one. So this is what you need to know, especially when you're dealing with exponents and such. So now factorization, one must be able to know how to factorize quadratic formula, squaring both side inequalities. This is one of the most important aspects, especially when we're dealing with graphs. Then simultaneous equation, nature of roots, and yeah. Right. What you can see from the paper, let me try to erase these things so that we were able to go through the paper. So what I will do, I will actually not gonna do all the questions, but I'll just go through the ones that I believe that you need to make sure that you put more effort on them. I'm not saying the ones that I'm not going to address here, they're not important, but they are. But I believe most of you guys can be able to get the answers correct. Right. For example, if you look at 1.1, you can see that from on 1.1, the format of this question actually it's addressing the things that I just said now. For example, if you look on the first one, it says solve for x. But with this, you can see that there is x into 2 minus x, which is equals to 0. So this is just straightforward. It's factorial, it's algebra actual. Already it has been factorized for you, then you just have to conclude. Remember, there's something that you need to understand when you're solving for x. If you have expressions like this, let's say x minus 3 and x plus 4, let's say is equals to, let's say 8. Because of this part on the right is not 0, since it's not 0, you cannot say x minus 3 equals to 8 or x plus 4 equals to 8. This is not acceptable. It's wrong. You do that only if it is equals to 0, then you can do that, which means we must first expand this expression and transpose the 8 to the left-hand side so that we write everything in a standard form. So it's very important for you to always look for that. Then now on the first one, already this is like it's just like the testing of factorization, but already it's factorized for you. Then this one is quadratic formula. And guys, when you are dealing with quadratic formula, you must always check if the equation is written in a standard form. You can see that it's in a standard form, where the a is 2, the b is minus 3, and the c is minus 7. And make sure you copy the correct formula in the formula sheet. So it's x equals to minus b plus or minus the root of b squared minus 4ac. Everything divided by 2a. Then that's why you can do your substitution. Minus into minus 3 plus or minus the root of minus 3 squared, 4 into 2 into minus 7. Put the brackets. Everything to the power 2 times 2. Then this will give us 3 plus the root divided by 4, because we are along plus and minus, or 3 minus the root divided by 4. Then now you have to work out what is inside the root sign. Obvious minus 3 squared will give us 9 plus. Then you'll have 7 by 4 is 28. 28 by 2, so it's 56. So 56 plus 9, this will give us 65. So we have root 65 and root 6. Then you work out round your answer to 2 decimal places. So when you work it out, that you're going to have 3 plus the root of 65 divided by 4. This will give us 2.77. So the first one will be 2.77. Then you're going to have 3 minus root 65 over 4. It will give you negative 1.27. So you must make sure that you round correctly. Substitution, and make sure you write the correct formula, guys. Don't cram the formula. Look at the formula sheet and make sure that some of you don't write these values of x. So you must make sure that you show almost all the steps. It's very important. Then now, the first one is straightforward. There's no need for you to expand it. So I'm just explaining this one. Then 1.1.3, this one is squaring both sides. You need to square both sides. And guys, when you're squaring both sides, you need to make sure that you check your answers at the end. Not all the roots satisfy the equation. So you find that in some cases, you need to make sure that you check. So this is squaring both sides. This is the part of inequality, guys. So if you look at 1.1.4, this is inequality. Even if we move on to the next question, you see, okay, here they did not ask about inequality, question 4. But if you look at the question 9 there, it's also the part of inequalities. Yeah, this is inequality. It's inequality, this one. 5x squared plus 4x is greater than 21x. It's also an inequality. Then another one, 10.1.3 is also inequality. 13.1.3 is also inequality. Then now, let me try to give one example of inequality actual. Let's say we're given the expression, okay. Let's say we have, as an example, we have x squared minus x minus 20 less or equals to 0. Then we are told to solve for x. Remember, when you are dealing with inequalities, always you must check if the equation is written in the standard form all the time. So if you see at this, it's already in the standard form. It's x squared minus x minus 20 less or equals to 0. So it means now after this, you have to factorize. Not putting equals to, but less or equals to, you continue with the inequalities sign. Remember, the inequality sign changes when we multiply by negative or divide by negative sign. But in this case, we do not do anything. We don't have to put equals to, we must put less or equals to. So factors of x squared here, it's x and x. Factors of 20, that will give us negative 5. Negative 1, we'll have 5 and 4. 4 times 5 is 20. But the sign that we're going to use them here, they'll give us minus, which means we're going to use different sign. So we're going to have minus and plus. Minus 5 plus 4, it's minus 1, which means this is the correct one. We're going to have minus 5 plus 4. Then from there, we need what you call the critical values. Critical values like you're solving for x here. So we're going to have x equals to 5 or x equals to minus 4. Then from here, you draw a number line to represent those critical values. Which one comes first between 5 and minus 4? Obviously, minus 5, 4 on the number line, followed by 5. Then what we're going to do is, we can say, give me any value bigger than 5. Let's say 6. If we plug it where there is x here, 6 minus 5 it's 1, so it's positive. And 6 plus 4, it's 10, it's also positive. So positive times positive is positive. And this one gives us negative, and this one gives us positive. You can confirm that. Remember, it's not always that you get positive here, but you need to check your answers, okay? Right, then finally, we have to look at our inequality sign. Our inequality sign says we have less than. Less than, what does it mean by less than? If the sign says less than or equals to, it means we have to look for the answer where there is a minus. So where is the minus actually? So it means here the answer is between minus 4 and 5, because this way we have minus. You can also use the part of the graph, it's also fine. So it means in terms of the answer, we'll say the x is between minus 4 and 5 less than. So equals to, because it's included. Remember, we write the same sign, but they don't mean the same thing. It means that x is bigger than minus 4, but less or equals to 5. So this is the correct answer. Remember, one other thing, you need to know that it's not about having the answers in between all the time. If this sign here was greater than, it means our answers, we're going to allocate, like to locate the answer outside, so where there's a plus. And how do we actually get these answers where there's a plus? All right, there's an approach that I usually explain to my learners to say, if you want an answer that is not in between two values, it's just outside, just here and here. What you can do, you can hold your hands like this. Bafan, we call them bafan. So this is less than, this is greater than. So what you can do is you can just say, okay, fine. To get the answer, you just say x. Yeah, then you say or, then you put x. Then your left hand, you look at you put your hand like this, the left one. So this is your less than. You put it there where there is x, you're gonna have less than. Then this one is greater. Then you're gonna have greater than. Yeah. Then now you bring down your values. You're gonna have minus 4 here, and you're gonna have 5 there, which means because there's an equal sign here, it means you include both values. So we use this. But if the answer is in between, we use less than. If the answer is between two values, we use less than. But if it's outside, then we use our two hands, less than. Bafan, we call them bafan. So this is what we need to know, especially when we're dealing with inequalities. Some other method, they usually, like in other methods, they use graphs. You can also use it. There's no problem with that. It's very important, guys, to know this. Okay, then now, okay, let's just go through the inequalities part first, at least to address the inequality part. Then we'll move on to the other. Okay, so it means you take the decision based on the sign, the inequality sign. Less than means you consider answer where there's a minus. Greater than, you consider answer where there's a plus. Right, then now, for example, if we have, let's say we have this expression, we have 3 minus x into x plus 1 less than 0. Remember, in most of the case when we are solving inequalities, you write the equation in a standard form. You factorize, you get your critical values, then you draw a number and then you decide. But already look at this. This expression is already factorized for you. So is there need for you to write in a standard form? No need, because I see most of the learners when expressions like this, they say they remove brackets and they will come back again to this expression. So to avoid that, the equation is already factorized for you. So there's no need for you to factorize anymore. What you can do is just go straight to the critical values. So your critical values here, I said it's like solving for x. If you put it somewhere here, let's say x minus 3 into x plus 1. You don't have to show this. You don't have to show this. So 3x equals to 0, or x plus 1 is 0. So it's like your x will be equals to 3, or your x will equals to minus 1. Then you draw your number line. Which one comes first? It's minus 1 followed by 3. Then what you do, you can just choose any value bigger than 3. Any value bigger than 3 can use 4. You plug it where there is x. 3 minus 4, it's a minus 1. And 3 plus, I'm say 3 minus 4, it's minus. 4 plus 1 is 5, which is a plus. So negative and positive is negative. What does this mean? It means if you use any value bigger than 3, the answer will be negative. So it means here you're going to have plus and minus. They alternate, but you can still confirm. You see that you mustn't claim that always here you have minus, you have plus. The sign can change. But now let's look at our inequality. Our inequality says less than. Less than means we look where the answer is negative. It means we have to locate the answer where the answer is negative. It's very important. So it means here our answer is where? Our answer is below minus 1 and above 3, which means we're going to use this afar, because it's not between numbers, it's outside. So it means what you're going to do is just write x here and write or x there. Then now you write the inequality sign after x, and also the another inequality sign on the right. So this is greater. Then now you look at the value, the critical values. Then here you have -1, and there you have 3. Since there is no equals to, then this is our answer. So it means in terms of this 3 marks here, it means 1 mark for the critical values and 1 mark for the solution. So it's very important for you to, like, you must know how to actually determine this. Right? Then now, I believe you are now following. I believe you are now following. I'm not gonna do all the questions. Want to spoon feed, you have to do some of them. You just pause the video and you try to solve them on your own. Right? Then for the other one, it's the issue of, okay, let's say there's no inequalities here. Here we have an equality, then you just have to factorize first. Even here, but here you have to take a common factor. You can either take a common factor or, for example, if we were to solve it, then this we're gonna say 6x minus 2x squared less or equals to 0. How many terms are we having? 2 terms. Usually when we have 2 terms, like, you can either try to look for a common factor. If there's no common factor, then try to look for maybe the difference between 2 squares if it's there. For example, if you look here, we have a common factor. We can say our common factor is 2x on x. So if I take x here, I'm going to remain with 6. Then here I'm going to remain with 2x. Then less or equals to 0. Then we have to get the critical values. Critical values is like we have x into 6 minus 2x equals. You don't have to show this in your paper. So x equals to 0 or 6 minus 2x equals to 0. So you're going to have 6 equals to x, then divide by 2 both. So it means you're going to have x equals to 0 or x equals to 3. So now you're going to construct your number line. Which one comes first? 0, 3. Then you look for any number bigger than 3 there. So it's 4. If you plug 4 here, this will be positive. You plug where there is x, you put 4 here. So you see that 6 minus 2 times 4, this will be 6 minus 8, which will be negative. So we're using plus and minus. It means this will be negative here, and that will be positive, and that will be negative. You can also confirm. For example, if you take values that are between 0 and 3, let's say 2 or 1, if you substitute whether it's x by 1, this will be positive. 6 minus 2 times 1 will be 4. It will still be positive. Positive times positive is positive. So, but now we take the decision based on the inequality sign. The inequality sign says less than. Where is the less than? Less than it's outside. So it means we use wafana. So what we're going to do, we put the x first, or then the x, then the less than, then the greater than, then now we put our critical values is 0 and 3. Because there is equals to now, then we're going to say equals to, we're including. Another way to do this is to rearrange it to say, okay, we have 6x minus 2x squared less or equals to 0. We rearrange it, it's going to be minus 2x squared plus 6x less or equals to 0. We multiply by -2. Remember we said once you multiply by negative sign, the inequality sign changes. So this will be x squared minus 3x greater or equals to 0. Then we take a common factor, which is the x, into x minus 3 greater or equals to 0. Our critical values will be x equals to 0 or x equals to 3. Then we draw our number line. The number line will be 0 and 3. Now with this, you confirm. You take any value bigger than 3, it's 4. If you plug 4 where there is x, this will be plus. 4 minus 3 will be plus. So positive and positive is positive, which means you're going to have a negative and positive. That's why you see the inequalities are not, the signs are not the same because we did not change the sign. Right now, if you look here, we take this in based on where there's greater than is plus. So where's the plus? The plus is also outside. We're still going to use the file, we'll still get the same answer. So we're going to have x less than or equals to 0 or x greater or equals to 30. So the answer will still be the same. This answer will still be the same. So it's very important, guys, to know this. And guys, for this question, I think there's a typo here. This is supposed to be 2 here, 2 plus x. Yeah, just correct it. It's 2 plus x. 2 plus x. This is just a typo. 2 plus x. I believe you are following, guys. I believe you are following. All right, right. Then now, with inequalities, I think I have addressed it. Let's move on to in a simultaneous equation. And guys, there's something that you need to know about simultaneous equation. It's very rare to find a simultaneous equation where you find that it does not have factors. Then you have to use quadratic formula that gives you decimals. Most of the simultaneous equations in the exam are factorizable, which means that when you are given a simultaneous equation where it's not factorizable, then you need to make sure that you check your work well. Something's wrong. You need to make sure that you check. Okay, just a minute, guys. I want to answer a call. Okay, guys, apology. I was busy with something. My apology. All right. In most of the cases, when you are given a simultaneous equation, guys, most simultaneous equations, they are factors. So make sure that when you are dealing with simultaneous equation, if you find that, your expression is not factorizable, you must go back and check your workings. And let us go through this. Okay, before I go to simultaneous equation, let's address the part of squaring both sides. The expressions that are involving such form, guys. Right. If you look on the first one, it says 2 minus x equals to the root of 2 minus 7x. Remember, we need to solve for x, and here to solve for x means you must get rid of this side. And how to get rid of the root sign, we have to square both sides, because we know when we have square root of 2 times square root of 2, this becomes 2. And remember, the square root of 2 times square root of 2 is the same as square root of 2 squared. That's why when we square, when we square, then we remove the root actually. This becomes 2. So this is the reason why we have to square both sides. The reason to square both sides is to remove the root sign. So in squaring both sides means we're gonna have okay, this will be 2 minus x squared. This will be the root of 2 minus 7 in all squared. What you do on the left, you must also do it on the right. So here we're going to have 2 minus x together with 2 minus x. Okay, fine. And this will be 2 minus 7x. Then we can simplify this. This expression will give us 2 by 2, it's 4, minus 2 by x is negative 2x. Negative 2x plus x squared. This is 7. Sorry, 2 minus 7x. Then we group the like terms. It's 4 minus 4x plus x squared equals to 2 minus 7. Then we group the like terms. This will be x squared minus 4x. Let's transpose the minus 7 to the right. This will be plus 7x plus 4. We transpose the 2 to the right. Minus 2 equals to 0. Then this will give us x squared minus 4x plus 7x is 3x plus 2 equals to 0. And we can now factorize this. Factors of x squared, it's x and x. Factors of 2, that will give us 3 is going to be 2 and 1. And the sign that we're going to plug here, when we multiply, they must give us positive. It means we must use same sign. And because we want positive 3, it means this will be plus and plus. Positive times positive is positive. 2 times 1 is 2. plus 2 plus 1 is plus 3. It satisfies almost the middle term and the last term. So we're going to say plus 2 and plus 1. So your x plus 2 is equals to 0, which is minus 2, or x equals to minus 1. But now, guys, when you're dealing with squaring both sides, you need to check your answers. And what does it mean by this? Where there is x here, you substitute by the values to confirm if the left and the right are equal. For example, where there is x, if you substitute there by minus 2 on the left, it's going to be 2 minus into minus 2, which gives us 4. So on the right, where there is x, we put minus 2. It will be the root of 2 minus 7 into minus 2. So this will give us the root of 2 plus 14. And 2 plus 14 is just 16. So what is the root of 16? It's 4. So this means this is the correct answer. Then we do the same for minus 1. For minus 1, where there is x, we put minus 1 there. 2 into minus 1 will be 3. And on the right, where there is x, we put minus 1. 2, the root of 2 minus 7 into minus 1, which will give us root 9, which is just 3. So it means the two answers are correct. So in most of the cases, you need to confirm your solutions, guys. Especially when you're squaring both sides, you check. So this is the correct answer. This is the correct answer. And in most of the cases, guys, it's not like sometimes you find that they can transpose x to the right-hand side. Then you must make sure that you rewrite it to be in a standard form before you start squaring both sides. I believe you are still good. All right, then now we're going to move on to the next part. Okay, let me continue. Fine. Let's address, okay, let me look for another. Okay, if you look at this expression, 4.1.3. You see that the equation, you need to remove the root sign. But before removing the root sign, you need to make sure that you rearrange the equation to be in a standard form. Otherwise, if you start squaring both sides, if the expression is like this, you're gonna spend a lot of time just to get the answer. So it means now from this, what we can do, we can say, okay, since we have x minus 3, the root of x minus 4 equals to 0. Because we want to get rid of the roots, and we can just transpose this 3 root x to the right. So we're going to remain with x minus 4 equals to 3 to the root of x. Then now, since we have this, we can now square both sides. Right, this will become x minus 4 and x minus 4. Then this one, because it's not inside the square, it will be 3 squared, which is 9. And what is the root of x? In all squared, will give us x. That means this will be 9x. Then the rest you can simplify and get. But remember, you need to check your workings. You need to check your workings. Okay, then now we can move on to the issue of exponents. Obviously, not necessarily exponent, but simultaneous equations. Quadratic formula, I've already addressed that one. I'm not going to talk about it. Okay, let's talk about simultaneous equation. In most of the cases, guys, when you are given simultaneous equation, you need to start with the equation which is simple. For example, it's not complicated actually. So when we have 2x minus y equals to 3, let's call this equation number 1. So we're going to call that equation number 1. And the second one, we have, what is this? X squared plus 5xy plus y squared equals to 15. Let's call this equation number 2. Obviously, we're going to start with this equation, which is not complicated. Obviously, the equation 1, we're going to say from equation number 1, where we have 2x minus y equals to 3. We can either make x the subject or y, but yeah, in order to avoid fraction, let's make y the subject of the formula. So it means we're going to have, we can transpose y to the right-hand side, 3 to the left. So this will be 2x minus 3 equals to y. So we call this equation number 3. So what we're going to do is we're going to have to substitute equation number 3 into equation number 2. What does it mean? Where there is y here where we put 2x minus 3. So this will give us x squared plus 5x into where there is y, we're going to put 2x minus 3. We substitute by 2x minus 3. So same applies, 2x minus 3 squared equals to 15. So we simplify, this is x squared plus 5x times 2x, this become 10x squared. 5 times 3 is 15x. Then we simplify this is 2x minus 3, 2x minus 3. We transpose the 15 to the left-hand side, then this becomes 0. So we can simplify this to, this is 10x, or 11, sorry, 11x squared minus 15x plus, we remove this. This will give us 4x squared minus 6x minus 6x is minus 12x plus 9 minus 15 equals to 0. Then we group the like terms. So we have 11x squared plus 4x squared. This gives us 15x squared. Then minus 15x minus 12, it's minus 27x if I'm not mistaken. Then from like here, 9 minus 15, this gives us negative 6 equals to 0. And here we can look for a common factor. We can divide by a number that goes into 15, 27, and 6. What is that? I believe if we divide by 3, this will leave us with 5x squared. 27 divided by 3 is 9x. 6 divided by 3, this will give us 2 equals to 0. So we're going to make 2 pairs of brackets here. Factors of x squared, this will give us 5x. And x factors of 2, it means I have to put 2 here and 1. Why? Because 5 times 2 is 9, it's 10. And with 1 will give us 9. So here we are going to use different sign because the last term is a negative sign. So it means you can say negative and positive. You can check. 5x times x is 5x squared. 5x times minus 2 is minus 10x. And plus 1 times x is positive x. And what is minus 10 plus 1? It's minus 9. Sorry, which means the x is equals to minus 1 over 5, or x equals to 2. But still, we are not done because we have to solve for x and y. And to do that, it means we have to use equation number 3 to say, okay, already we got the value of x. The first x, it's minus 1 over 5. And what is the y value? It means where there is x in this expression, we have to substitute by minus 1 over 5 minus 3. And this will give us minus, let's say minus 2 over 5 minus 3. And 5 times 3 is 15. Minus 2 minus 15 is minus 17 over 5. So we have the first one. Then the second one, it means we're going to say when x is how much? 2, what is the y value? It means where there is y, we're going to say 2 into, from this equation, 2 minus 3. 4 minus 3, this gives us 1. So it means in terms of coordinate, we're going to say when you have 1 over 5, the y value is minus 17 over 5. And the other one, when x is 2, the y value is 1. So this is the answer. This is the answer, guys. You need to make sure that you check your workings. Okay? Yeah. Always start with the complicated, like with an equation which is not complicated. Remember, from the equation, we can make x the subject, but the problem is to avoid fractions, because if we make x the subject of the formula from the first equation, then we're going to have fractions. So to avoid fractions, then it means you have to make y the subject of the formula. Unless if both sides, whether you make x and y, you're going to have fraction, then you have no choice. Okay? Then now, okay, let's check. We still have simultaneous equation, but this one include exponents. You need to simplify first. Also, you see here, you can make y the subject of the formula, 9.2. Here you can either make x and or y the subject of the formula. Yes, then now Okay, this one we'll look at it at the end. Squaring both sides. You see what I was telling you, that you don't just look at the question and start squaring. From here, it means you must either transpose minus x plus 1 to the right-hand side first. Then that's why you can square both sides. Yeah. For example, if you look at 13.2, let's look at 13.2, guys. 13.2 is not in Martinez, it's just it's just a given information. They said given x plus 1 over x equals to 4. This is what you are given. Then they say determine the value of this. Look at this guy. Here we want x squared plus 1 over x squared, and here we have x plus 1 over x. They want this. It means we have to use this to get this. And now we're going to do that, guys. It's just common sense. We want to end up with x squared plus 1 over x squared. Here we have x plus 1 over x. It means this is what we must use in order to get this. So it means we're going to say, okay, fine. Since we know that x plus 1 over x equals to 4. And we want something that is to do with x squared. So it means what we can do is let's try to square here. Look at this. If we do this, we say x plus 1 over x together with x plus 1 over x. This gives us 16. X times x, it's x squared. We are removing the brackets. X times 1 over x. If you take x, you multiply by 1 over x. You see that the x and the x will divide. You remain with 1 plus 1 over x times x, still remain with 1. Lastly, 1 over x multiplied by 1 over x is 1 over x squared equals to 16. You see that we are getting what we are looking for, this one. But now we have to group this. I will say x squared plus 1 over x squared plus 2 equals to 16. Then transpose the 2 to the right-hand side. So it's going to have x squared plus 1 over x squared is equal to 16 minus 2. This gives us 14. So it means 14 is the correct answer. I believe you are following. Remember, practice makes perfect, guys. Another thing is, look at this. Now we want the cubic. Imagine with cubic, it means we're supposed to make that cubic. But now, like, imagine you have to do this. Okay? Then if we have, let's say we have x plus 1 over x, we know it's equals to 4. If we make this to the power of 3, and we mark that to the power of 3, look what is going to happen. So it's like you're having x plus 1 over x with x plus 1 over x with x plus 1 over x equals to 4. Already, maybe these two already have, this two is this one. We got the answer for this when we expand these two. Okay, let me just use a different color. Even if we take the first one and the second, but I wanted to use this one, these two, this one and that, it is our x squared plus 1 over x squared. No, not necessarily x squared plus 1 over x. But now, look, guys, when we take, let's say we expand, okay, let me not, okay, let's say if we take this and combine with this. Okay, first of all, let me just do it like this so that you can understand. If I actually take this, but even if we use that one, it was going to get the answer. If we take the x plus 1 over x together with the x squared plus 1 over x squared, look what we're going to have. Okay, when you multiply this times this gives us what? X cubic plus, when you multiply this, is this one with that, okay, this one with that is gonna be, it's like a times x with 1 over x squared. See that the x and the x will divide. So we're going to have 1 over x here. Then now the second one, we're multiplying 1 over x with that. This still is going to be, this will be x actually, plus 1 over x multiplied by 1 over x squared. This will be 1 over x cubic. You see that now we're having x cubic plus 1 over x cubic plus this part 1 over x plus x, and is equals to this. And what is this? This we already know it's 4. And what is this? This we already know it's 14. You see? Then now 4 multiplied by 14. 4 multiplied by 14, this will give us 56. So we're going to have 56 here. This one will give us x cubic plus 1 over x cubic plus, already know this expression here. It's given, it's 4. So if you transpose the 4 to the left-hand side, will be 56 minus 4, which will give us x cubic plus 1 over x cubic. So you can see that x cubic plus 1 over x cubic. This gives us 52. Even if I've used that approach, I'm still going to get the same answer. Guys, I believe you are following. I believe you are following. I do not want us to go far, but the approach will still be the same. Okay? Yeah, there are many ways to skin a cat, guys. Practice makes perfect. Right? Then now, we can move on to the issue of exponents and surds. I don't want to spoon feed you guys. Some of the questions you need to do them on your own and check if you're getting them correctly or not. Okay? Yeah, okay, let me just try to erase here. Okay, let's now continue. Okay, let me just go up. Nature fruits, okay. Okay. Yeah. Before I look on the nature of fruits, let's look on the exponents first. 1.3. 1.3, it says if you take 6 to the exponent of 6 plus 6 to the exponent of 6 up until, sorry. Then they say solve for x when we have 6 to the exponent of 6 plus 6 to the exponent of 6. 6 of them. It's like, look at this. 2 plus 2 plus 2 plus 2 plus 2 plus 2 is how much? 1, 2, 3, 4, 5, 6. 2 plus 2 plus 2 plus 2 plus 2 is the same as 2 times 6. 6 2s, right? 6 times 2, right? So we're going to have 2 6 actual, right? Then now it means here when we have 6 to the exponent of x times 6 to the exponent of x, 6 to the exponent of x is the same as 6 multiplied by 6 to the exponent of x, which is equals to 6 to the power of 6x this side. Then now the base are the same here. We take one base and we add the exponent. This will be 1 plus x, which is the same as x plus 1 equals to 6 to the power of 6x. Now the base are the same, then we can equate the exponent. So it means x plus 1 equals to 6x. We transpose the x to the right-hand side. This will be 6x minus x. This we're going to have 5x, then divide by 5. It gives us 1 over 5. The exponent, guys. I believe you are following. So the answer is 1 over 5. Exponents and surds. But this is just exponents. Okay? Then let's look on the other one that is involving exponents. Okay, this one. But this one is involving exponents and surds. And usually they say simplify this without using a calculator. So how are we going to do this? So it means we're going to say we have x equals to the root of 10 to the exponent 1009 divided by the root of 10 to the power of 1011 minus the root of 10 to the exponent 1007. By the way, guys, here we need to simplify this without using a calculator. First of all, let's look at the exponents. Here we have 10 to the power 1009, 10 to the power 1011, 10 to the power 1007. What we can do is we can reduce these powers to have the same exponents. For example, it's either we can remain, we look at the smallest number, we have 1007, which means we can rearrange 1009 to be 1007 plus 2, yes. Oh, no, necessarily, yes, I apologize. Then we have 1011, this is the same as 1007 plus 4. Then we have, yeah, it means we can just, we want everything to have 1007 in it. I believe you are following. Or we can also reduce it to have 1009. It depends with our choice. You can also change everything, like maybe to have exponents of 1009. So it means if it's 1009, it will be the 1011 will be 1009 plus 2. Then the 1007 will be 1007 minus 2. It will still give us the same answer. So it means here what we cannot do, we're going to say, okay, this is the same as the root of 10 to the power 1007 plus 2 divided by the root of 10 to the power 1007 plus 4 minus the root of 1000, 10 to the power 1007, because we want everything to have 1007 in it. So we know in terms of exponents, when we have x to the power of x plus y, this is the same as a to the power of x multiplied by a to the power of y. So it means we can still expand this to have 10 to the exponent 1007 times 10 to the exponent of 2 divided by 10 to the exponent 1007 times 10, so 10 to the exponent of 4 minus the root of 10 to the exponent 1007. And remember, we know in terms of such form, the root of a times b is the same as the root of a times the root of b. So we can expand this to be root of 10 to the power 7 multiplied by the root of 10 squared, which is just 100, over the root of 10 to the power 1007 multiplied by the root of 10 to the power 4, which is just 10,000, minus the root of 10 to the power 10 to the power 1007. Apologize. So it means if we rearrange this, we're gonna have the root of 10 to the power 1007. What is the root of 100? Is 10 divided by. We can take a common factor here. This will be a root of 10 to the power 10,007 into. So look at this, the root of 10 to the power 4. 10 to the power 4, it's actually a what? 10,000. But what is the root of 10 to the power 4? It will give us 100. Remember, we've taken a common factor. Minus, here it will give us 1. So you see that this and this will divide, then we're going to remain with 10 divided by 100 minus 1 is 99. So I believe you are following. So it means the final answer will be 10 divided by 99. Okay, guys. So that is the answer. So SADS. I believe you are following. I believe you are following. Okay? Right. Okay, now I want us to move on, guys. We're about to finish. Okay, we went through the issue of exponents for these two. Okay, fine. How about this one? This one, like, it has to do with the factorization. Why? Because now here we have, let's say we have 2 to, or because we have 2 to the power of 2x minus 6 times 2 to the power of x equals to 16. Look at this. This is the reason why we want to have factorization. Because look, we know 2 to the power of x multiplied by 2 to the power of x. In terms of exponents, what do we have? We take one base and we add. This will be to the power of 2x. You see, that means to the power of x times to the power of x is the same as, which is the same as to the power of x in all squared. It means when we have this expression, we can rewrite it like this. So it means where there is this, we can say to the exponent of x, everything to the power of 2 minus 6 multiplied by 2 to the power of x. Then we transpose the 16 to the left-hand side. So because of this, we have to the power of x, two of them, right? We're going to say, let us let where there is to the power of x to be k. So it means where we see to the power of x, we're going to replace it with k. It's going to have k squared minus 6k minus 12 equals to 0. You can even factorize without letting. So factors of k squared is k and k. Factors of 16, that will give us 6. 16, we have 8 times 2, it's 16. And within 8 and 6, we can get 6. But the sign that we're going to use here must be negative. So it means we must use different signs. So we're going to have minus and plus. Let's check. Minus 8 plus 2, it's minus 6, correct? Negative and positive is negative, so it's correct. So we're going to have minus 8 plus 2. That means the value of k equals to 8 or k equals to minus 2. We're not solving for k, we're solving for x. It means where there's k, we're going to put to the power of x equals to 8 or to the exponent of x equals to minus 8, minus 2. So we can expand this or we use logs. There's no problem. Oh, by the way, the grade 11s don't know logs. So obviously this, there's no solution because of this minus. So it means x equals to 3 is the answer. But you should be careful. It's not about letting. Remember, for sometimes, let's say you have 2 to the power of x plus 2 plus, let's say, wait, guys. Okay, let's say we have 2 to the power of x plus 2 equals to 2 to the power of x equals to 20. Then we are asked to solve for x. You see now, this is x plus 2 is not 2x. It's unlike this one. So it means this one we need to expand. It's not about letting. So we're going to say to the power of x times 2 to the power of 2 plus 2 to the power of x equals to 20. I believe you know why I've done this. Right now, here we have a common factor. Now we can say, oh, by the way, we can take common factor as 2 to the power of x. This becomes 2 to the power of 2 plus 1, which is equals to 20. So you're going to have 2 to the power of 2. 2 to the power of 2 plus 1, this becomes 5 equals 20. So we divide there by 5 and divide there by 5. This will give us 2 to the power of x equals to 4. And 4 is the same as 2 to the power of 2. Now the base is the same. So it means x equals to 2. I believe you are following, guys. I believe you are following. Okay? Right, then now, okay, the issue of exponents, I think I have addressed it. Okay, I'll first check if there is not any other question which I believe I can look at. Okay. Let me check. Okay. Yeah, remember I said there's some typos here again. The expression according to the question paper, here it's supposed to be x. So let's correct this. This should be 2 and this one should be x. So let's write this. It says we need to solve for this is the root of the root of 2 minus x times the root of 2 plus x. This is equal to 0. Right, here we're going to use Sard's expression. Now, look at this. We know in terms of Sard's, let me just use a different color, that in terms of Sard's, when we have the square root of a times b, this is the square root of a multiplied by the square root of b, right? And we know that the square root of any number is that number, the power of 5. Okay, fine. We can use this if you want, but I wanted to address this. Look at this. Here we have a sign, the root sign, and here we have the root sign, two of them. But look at these expressions are not the same. So it means you can take this one as the a and this one as the b. So we have the a here, and then we have the b, which means we can return them back by putting one square root and multiply both of them. So it means this is the same as the root of, we put one root sign and we multiply root 2 minus x together with the root 2 plus x. Because if it's like this, we can still say the root of this multiplied by the root of that. I hope you are following now. Equals to x. Then after doing this, we can now remove the square root by squaring both sides. So if you square both sides, this will become the root of 2 minus x times the root of 2 plus x equals to x squared. Now let's remove the brackets. What is root 2 times root 2? Is 2. Root 2 times x, this will give us a plus root 2x minus x times root 2. This will be root 2 times x. Then minus x times positive x, this will be minus x squared equals to x squared. So grouping like terms here, you're going to remove f2 because this will be 0. Then we transpose minus x squared to the right-hand side. This will become x squared plus x squared, which will just give us 2x squared. Then we divide by 2 and we divide by 2. So it means now the x squared will be equals to 1. So with this, we can put the root sign and we allow plus or minus. So the x will be plus minus 1, or we can just say x equals to 1 or x equals to minus 1. And since we are dealing with signs, we need to confirm, guys. We don't just plug the answers, we need to confirm. What we can do is where there's here, we can put 1 there, and then we can put 1 and confirm the answers. If it's 1 beside, let's check. Remember, we can also do it from here. If we put 1 here, this will be root 2, and if we put 1 here, it will be root 2. And what is root 2 times root 2? Root 2 times root 2 will be 2. So we're going to remain with the root of 2. And the root of 2 will give us decimals. And when we put, then the answers will not be the same. So let's try negative 1. So we're going to also do that. Let me check if... Okay, it's minus. Oh, okay. Okay, now I understand. Now I understand. Because here we're going to say root 2 plus 1 and root 2 minus 1. It's not going to be 0. Oh, I apologize, guys. It's not going to be 0. So when we work it out, so we'll have to use our calculator. But this is how we find the answers, guys. Okay? Yeah. Then now, yeah, there's a typo here in terms of the paper. The way it was shown, it was saying the root of root 2 minus x into the root 2 plus x instead of that one. Because if we use this one, somehow will be stuck. Because we're going to say the root of root 2 minus x, then the root of x. Okay, let me just leave it, guys, because there was a typo as I explained. Right. The other thing is the issue of the nature of roots, guys. Sometimes in the exam, they can ask you to determine the nature of roots. For example, by looking at the expression, we can know, for example, if I can just choose one, like then, for example, in grade 11, we have x squared minus x minus 6 equals to 0. I want to know the nature of roots for this one. So remember, when I determine the nature of roots, we must know the a, the b, and the c. We have there, right? So we're gonna use discriminant. This discriminant actually we get from the quadratic formula. The expression inside the root sign, it's our discriminant. So it's b squared minus 4ac. So now, what is our b? Our b it's minus 1. The a it's 1, and the c it's minus 6. If we work it out, this will give us this 1 plus 24. This will be 25. Right, we want to explain the nature of roots for 25. Look at this. 25, it's not equals to 0, right? It's a number bigger than 0. It means the roots are real. The roots are real when the discriminant is positive, right? And again, let's look at this. It's 25 a rational number or irrational? Remember, we decide the part of rational and irrational if we checked for real. But if it's non-real, we're not going to talk about it. So we want to decide whether 25 it's rational or irrational. To decide that, we want to check whether it is a perfect square number or not. Remember, if it's rational, when we take this number and put it inside the square root, it must give us a whole number, not decimal. So it means this is a rational. It's a rational number because the square root of 25, it's 5. But let's say we have 26. 26 will be irrational because the square root of 26 will give us decimal numbers. So it will be irrational. So the roots are real, the roots are rational. And since it's not equals to 0, they are unequal. Why? Because 25 is not the same as 0. So it means roots are real, rational, and unequal. But in some cases, let's say if they say determine the value of k or the values of k for which, let's say, x squared minus 2x minus k, let's say minus k equals to 0, we'll have, let's say we'll have non-real roots. Yes, non-real roots. We want the value of k which will make this expression to have non-real roots. We know for non-real, the discriminant, the delta must always be less than 0. It should be negative. Must be negative. And what is our discriminant? Discriminant is b squared minus 4ac less than 0. So now we can get our a, our b, and c. Yeah. So because our equation is in the standard form, the a it's 1, the b it's minus 2, and the c it's minus k. So we're going to substitute by everything there. This will be minus 2 squared, 4 into minus 2, no, minus, it's 1, sorry. 4 into 1. Okay, I apologize, guys. So it means this will give us 4ac. The b it's minus 2. The a is 1, and the c is minus k. This is less than 0. So when we multiply this will give us, let me try to raise here. Okay, it means now we're gonna have 4 minus 4 times 1 is minus 4. Minus 4 times k is plus 4k. This is less than 0. Then we have to solve for k. It means 4k, we're going to transpose 4 to the right-hand side. It's going to be negative 4. Then we divide by 4. This will be minus 1, which means when we use any value less than minus 1, then the roots will be non-real. And let's confirm. Give me any value less than minus 1. Any value less than negative 1. By the way, what do we have? Minus 1, minus 2, minus 3. Let's use minus 2 there because minus 1 is less than minus 1. So it means our expression will be x squared minus, then we're minus into minus 2 because the k is minus 2. So it will be x squared minus 2x plus 2 equals to 0. Let's determine the nature of roots. B squared 4ac. Right, where there is b, we're going to substitute the b with minus 2. This will be minus 2 squared. A is 1 and C is 2, or C is 2, sorry. So this will be 4 minus, C is 2, by the way, guys, plus. So this will be minus 8. You see that 4 minus 8 is minus 4, which is less than 0. You see that the roots are non-real. Roots become non-real when the discriminant is negative. Very important. Okay? Yeah. So, yeah, I think I've addressed what you guys need, you're supposed to know. And wish you the best, guys. Practice makes perfect. Thank you. Thank you very much for listening. Arigato. Ke a re leboha. Ha cancer. Inkomo. Yes, yes. Thank you. Thank you, guys. Yeah, if you practice as many questions as possible, then all will be well. Okay? Bye, guys.